Okay, since they're setting up and I'm all set up. So good morning everyone. Thanks for showing up in such large numbers. It's been a while since I've had a large audience. I'm not very sure about this talk in the sense that I didn't know what audience to expect and I don't know what to expect. So if you have questions during the talk, you can stop me. I often have a lot to say, but if it's of no interest, I can always change direction. So I am Prabhu. I have been using using Python since 1999, and I've been using the Nthought tool suite, which is an open source tool suite that's available under a BSD license that primarily Nthought maintains for maybe since 2003, 2004. And it's a very powerful tool set that we use internally in Nthought. And pretty much all of our commercial offerings as well use our open source tool stack. So essentially what we do is we build our applications, our client-side applications. What we can roll into an open source part, we roll into an open source part. So the EBS itself has like a lot of pieces. I don't have slides now, so the formal talk will start soon. I'll just give you a brief overview. So what I'm going to talk about primarily is, I'll talk to you about ETS. In a sense, it's going to be a redux of the talk or the tutorial that was there yesterday. It's going to be a redux of that, compressed form. The idea is, these basic building blocks that we provide are extremely powerful. So what I'll start off with is a demo, a set of demos, which will show you the kind of rich applications that you can build. Now, I will not talk about, these are all desktop applications. This is not a web app. Okay? They are meant to be run on your desktop, which is primarily the use case for most scientists and engineers. Very few people actually run any computations offline, especially when they're doing their rapid development. At least not until now. Things have changed a lot. Things are changing a lot. But still, if you look at anybody who's doing serious number crunching, their primary first phase, their environment, is on a single desktop. So that's going to be the focus. The question is, if you're targeting an audience, you're targeting people who are not necessarily the best programmers. So you're looking at people who are engineers and scientists who like to do science and engineering. They are not Pythonistas, and they don't care. They'll use any language you give them. Okay? And you'll be lucky if they don't use Fortran. You'll be lucky if they don't use C, and you'll be lucky if they don't use C++ very badly. Many of them will declare global variables. Many of them will have functions that have like 30 arguments. So they're not necessarily the best programmers. So then, how do you approach dealing with such people? Obviously, you can't say, hey, we have this thing where you just write some random code and it's going to be good. No. You have to follow a process. You have to use proper software engineering. But the idea is, you have to think of it from the perspective of building applications, building tools for such people. Okay, so you've got to make it as easy as you possibly can. So the focus is going to be, so what I'm going to do is, the outline will be, I'll take up a few applications, large applications. I'll start off with Miami because that's something I'm familiar with. I'll show you some very cool features. All of these are built on top of the ETS tool stack, which basically means I'm trying to show you a demonstration of, hey, you know what? If you pay a little attention, if you check out our open source repositories and look at our documentation, you too can build applications like this. I'll do a few of these demos, and then I will get down to actual code. So I will be showing you a lot of code. I will show them interactively. I will take a simple problem, which is scientific, which I again use the same problem that I use in the tutorial, and quickly walk through how you build a solution with a small subset of the tool stack that we provide. Okay? To give you a feel for, well, it's not just these fancy pictures that I am showing you, but here's actual code, the complete code. And it's not as if I'm cutting out parts of the code. It is code that I you can build interesting applications very easily. Okay? But it requires, obviously, there's a learning curve. So I have a problem with my Mac. There's an update that seems to have broken it whenever I go to full screen, so I'm going to have to, I can't do this full screen. So before we begin, how many of you have got the John Hunter? How many of you have used Matplotlib? Matplotlib. So John Hunter was the author, is the creator, the original author, lead developer of Matplotlib. He was the keynote speaker this year at Sci-Fi 2012 in the US. And so John Hunter was the father of Matplotlib at some level. Very sadly, he passed away right after the Sci-Fi keynote that he gave, about a month later. He was a good friend, he's a really great guy, and it's a huge loss to the community. Matplotlib forms like one of the central features of scientific computing in China. We won't be doing any of our partying without Matplotlib. The second person I'd like to remember is around KG. KG was also someone everybody here knows, right? Is there anyone here who doesn't know KG? So you're not sad. KG was an inspirational figure to a lot of people. He was quite an extraordinary person, very dedicated and devoted to the cause. He's done so much for our community. We should remember that. Okay, so I start off my talk with, as I said, a bunch of demos. So the first thing I'm going to demonstrate is MayaVi itself. So MayaVi is part of ETS and it's built with the tools in ETS. So the way MayaVi is set up is written completely in Python. It uses the AES and so what you see here is a three-dimensional scene, a mechanism by which you can interact with objects that you create here. So what I'm going to show you is something that I think is fairly cool. So what you see here is, I don't know if you can see that code. Just to get it. Fortunately, I can't change the font. What I'm going to do is, okay, I'll show you the code as we progress. I'm going to load some data from file. And then I'm going to show you an outline of that data. It's just an outline, so it's just a box. But notice that you can't see much of it. I will show you the actual code later on. It's actually recording all of those actions on screen in actual readable Python code. Okay. I'll open another file. So this is a picture of a shuttle. I hope you can see that. Okay, so some visualization, I just loaded up a file, did some visualization. The interesting thing here is, it's actually recorded every single thing that I've done on the screen. On my UI, I didn't write any Python code here, it's automatic. And it has recorded that into a Python script. So now if I say save that script, and let's call it say demo keyword. Cancel this, close that. And I can just, so let me just open that script. Let me open it in an actual real editor. You can see that, right? Can you at the back see the code? Yeah, so it's fairly readable, right? It says scene, this engine scene 0, ATK XML file data, it is not open some file. So it's readable Python code, you can edit it. But the cool thing is, I can go in here and run that Python script. And it replayed my entire set of actions. What's better is I can actually run it completely standalone. Edit that. I quit Maya itself, so you don't think it's some. That's a completely standalone, has nothing to do with Maya. As in, it's doing Maya, obviously it's writing a lot of Maya stuff there, but it's not running in the application, so you can actually run it standalone. So all of this is built out of tools that are entirely inside ETS. There's nothing outside, not pulled any tools. Plus, the entire application that you see there, the whole Maya application that I showed you, is basically using ETS. And you won't believe it, there are very few lines of actual UI toolkit code. This will run either on Linux, it will run either on WXPython or on Qt. And I don't have to write much of that as a user of this. Here's another UI. So this is a customized view of Maya. Okay? The kind of things that you can do. So again, I'll just show you a demo. So this is a Python script. What it's doing is it's solving a system of ordinary differential equations and showing you a trajectory of what's going on. This magic stuff that I'm doing on the scene here, the interaction here, is done through a library called VTK, Visualization Toolkit. And ETS provides a layer on top of that called TVTK, which essentially exposes that in a very Pythonic way that I can use very conveniently. The interesting thing here is I can change these equations on the fly. So if I change that, it actually updates. Let's say let's make it x squared. And you see the nature of the solution changes. If I want to change the parameters, I can change the parameters on the fly. So this is something that you can build using, again, ETS. So let's just quickly look at the code just to give you a feel for how it looks. So this is the source of this. It's documented, commented, looks reasonably pretty just to read, and it's about 142 lines of code, that entire application. So firstly, it's not going to be, I don't think you can beat that with the number of lines of code. Finally, I'll show you one more quick demo. So here's an extremely interesting application. What we're looking at is, there's another plotting library that ETS ships with called Charco. Charco is primarily used for 2D plotting. Okay? Maya is meant for 3D plotting. Now, Maya basically uses OpenGL only. Charco uses its own rendering layer, and it has different it doesn't in this case. It has an image rendering pipeline as well in the background. So what this thing is doing is it's actually embedding a Chaco plot inside a VDK based plot. Okay? And you can interact with it live. So what I'll do is I'll show you a quick demo. So what's happening here is they've built a layer of abstraction inside Chaco called Enable. And Enable has different backends. One of those backends is something that talks to VDK. So basically this is a CSV file that's been read. It has some commodity information. And this is a Chaco plot of some kind of a distribution along time for that particular data. The nice thing I can do is I can select regions here, drag the regions here. This is all Chaco. Okay? And what happens is as I do things on this, unfortunately the colors are messed up. But if we run the demo, it should be a lot clearer. You can see that it actually updates the plot live. Again, this is something that you can do with VDKs. So it's basically plotting a selection. When I'm essentially selecting a date region between those two images that I selected. Yeah, so yeah, unfortunately you couldn't see it, but the window was actually moving like that. Or I could change the selection itself, in which case it will show me the different set of plot points. Yeah. So that's just understand that this is just a quick demo that I'm showing you. But the idea is I can do a